All right, let's get right into it. AI and machine learning. You hear these terms thrown around absolutely everywhere, right? They're running in the background of our lives. But what are they, really? Well, today, we're going to pull back the curtain and actually figure out what makes these powerful ideas tick. I mean, think about it. How does Netflix just know the perfect show for you? Or how can a car possibly see the road and make decisions? It's all AI. That recommendation, that self-driving tech, even your email's spam filter, it's all part of the same family. So the billion-dollar question is, how on earth does it work? So here's our game plan. We're going to break it down into 5 key pieces. We'll start big with the idea of AI itself. Then we'll zoom in on the engine that makes it all run, machine learning. After that, we'll get into the playbook of how machines actually learn, take a peek inside the quote-unquote AI brain, and finally, we'll zoom back out to talk about data, the dangers, and what all of this means for our future. Okay, first things first, let's tackle the biggest term of all. What in the world is artificial intelligence? You can think of this as the giant umbrella, the whole universe that everything else we're about to discuss fits inside. At its absolute core, AI is really just the science of making machines smart. The whole goal is to build something that can do stuff that up until now we thought only humans could do. Things like reasoning, learning from mistakes, and solving tricky problems. And here's something that might surprise you. AI isn't some brand new thing. I mean, the ideas for it started way back in the 1940s, when scientists were just trying to figure out how our own brains work. The term machine learning itself, that was coined in 1959. So what changed? Why is it exploding now? 2 things: unbelievable computing power and just mountains of data to learn from. Okay, this is probably the easiest way to picture how all these buzzwords fit together. Artificial intelligence is the whole circle, the entire field. Inside of that, you've got machine learning, which is a specific way to achieve AI. And then, right at the very center, you've got deep learning, which is a super-powered version of machine learning that we'll get to in a bit. So let's drill down into that next layer. We're talking about machine learning now. This isn't just a part of AI. For most of the things you see today, it's the actual engine that's making it all happen. This is the classic definition, and it absolutely nails it. The magic words here are, without being explicitly programmed. See, in the old days, a programmer had to write out every single rule by hand. With machine learning, you don't do that. You just feed the machine a ton of data, and it figures out the rules for itself. It learns. So how does that learning actually happen? Well, you'll hear 2 words a lot: algorithm and model. The easiest way to think about it is this. The algorithm is the recipe. It's the set of instructions on how to learn. The model, that's the finished cake. It's what you get after you've used your recipe on a specific batch of ingredients. In this case, your data. Which brings us to the playbook. I mean, if a machine is going to learn, how does it do it? What are the strategies? Well, it turns out there are a few main approaches that pretty much cover everything. Okay, the 2 big ones you'll hear about constantly are supervised and unsupervised learning. Supervised learning is like studying for a test when you already have the answer key. You show the machine tons of examples where the right answer is already marked. Unsupervised learning, that's like getting a 10,000-piece puzzle dumped on your table with no picture on the box, and it's your job to find the patterns all on your own. Let's just look at the difference here. With supervised learning, the goal is to get really good at predicting things. Your email's spam filter is the perfect example. It learned what spam looks like by analyzing millions of emails that humans had already labeled spam or not spam. But with unsupervised learning, the goal is totally different. You're trying to discover patterns you didn't even know existed. Think about a company that groups its customers into different types based on what they buy, without having any predefined categories to start with. And then there's the third style, which is just so cool. It's called reinforcement learning, and it's all about trial and error. The machine tries something. If it works out well, it gets a little reward, a digital treat. If it messes up, it gets a penalty. You do that millions of times, and eventually it learns the best way to do something. This is exactly how AI masters complex games or how a robot learns to walk. So we know how they learn, but what's the actual hardware or, the brain that's doing all this? To understand that, we have to look under the hood and talk about something called neural networks. The whole concept is literally inspired by the squishy computer inside our own heads, the human brain. Just like our brains have all these interconnected neurons firing signals, an artificial neural network has layers of digital nodes that pass information to each other to figure things out. It basically works like an assembly line. First, the input layer sucks in all the raw data. Let's say all the pixels in a photo. Then, that data passes through the hidden layers, and each layer looks for more and more complex features, like edges, then shapes, then say whiskers and ears. And finally, the output layer puts it all together and gives you the final answer. Yep, that's a cat. And hey, remember that term deep learning from the beginning? Well, this is the secret sauce. What makes a network deep? It's just the number of those hidden layers. A simple network might have one or two, but deep learning models, they have at least 3 and more often hundreds or even thousands of layers, which lets them learn incredibly complicated things. And of course, not all networks are built the same. You've got specialized types. CNNs are like the eyes of AI. They're brilliant at understanding pictures and video. RNNs are the ears, great for processing sequences, like human speech. And then you have transformers, the absolute game changers that are powering all the incredible generative AI you're seeing today. Okay, let's zoom the camera all the way back out. We've been deep in the weeds of how this stuff works, but what does it all mean for us, for society? Let's talk about the big picture, the data, the dangers, and what's coming next. You know, what we're seeing is this fundamental shift in how we build things. The old way was based on rules. A human would write a giant list of if this, then that instructions. It was transparent, you could see how it worked, but it was super rigid. The new machine learning way is amazing because the system learns from data and can adapt. The downside, it can become a black box, where we don't always know why it made the decision it did. And that black box problem leads us to probably the single biggest challenge in AI today, bias. Because here's the thing, these models learn from data from our world. And our world, well, it's full of biases. So if the data you feed an AI is biased, the AI will be biased too. And that can lead to some really unfair and even harmful outcomes. The good news is, this is what the entire field is focused on right now. There's a huge push for what's called explainable AI, or XAI, which is all about cracking open that black box. There's a massive conversation around AI governance, basically creating the rules of the road. And of course, a constant focus on data privacy, because that data is the fuel for this whole engine. So that kind of leaves us with the ultimate question, doesn't it? This technology is getting smarter and woven deeper into our lives every single day. The challenge for all of us now is to figure out how we guide it, how we make sure that it's not just powerful, but that it's also fair, that it's transparent, and that it actually ends up being a good thing for everyone.